I've gone to mills all across the United States and in Europe and in South America, and I found the same problem, and they all blame it on something different. So they blame it on grounding, and when I first had this problem in the paper mill, what I did is I called the experts in, who were the manufacturers. They came in and they looked at it, and they said something to me, I was young and foolish at the time, but they said, nobody else is having this problem, just you are having this problem. So they said, probably when you rebuilt this paper machine, you cut the building steel system somehow. And they said, that's why you're having some kind of circulating currents. And so what I did was I CAD welded a 4-aught copper conductor to every beam in the paper machine down to the motor base, and from beam to beam, and to motor base, all the way down the machine, and took a 4-aught copper conductor, went outside and drove 25 ground rods and CAD welded those all to ground rods, and then ran a 4-aught copper conductor up to the drive, just as the manufacturer said that we need to do. That way it removed the problem of bearing fluting. So in my thought, well, I called the experts in, they gave me the presentation, they told me what was wrong, and I did it. It wasn't until about a year later, maybe a year and 2 months later, we heard the same noise coming out of a 200 horsepower that we had changed the bearings after we had redone the building ground system. Then I called the manufacturer back in, and they said, oh, well, it probably is something else. You probably have circulating currents because of you've got one transformer and 7 or 8 drives, where before you only had one transformer and one drive. And so they said the answer to this is to put a shaft, a brush, mounted directly on the shaft, and the brush would ride directly in the shaft. They very graciously sold these to us for $125 each, because it costs another $125 a piece to install. But at this point, I began to wonder, and I started checking. Checking the shaft to frame voltage, and what I found out was using a regular fluke multimeter, I could only see about a half a volt. I couldn't in my mind make that do the damage I had seen. So a friend of mine suggested that I use a battery-powered oscilloscope. When I did that, I saw voltage spikes up to almost 100 volts. And then I saw consistently voltage spikes from 50, 30, 50 volts. And so what I found out was, over testing, after we put this on, it would drop the shaft voltage down to about 5 volts. After about 10 to 11 days, the voltage would begin to build back up, and pretty soon this was not any value whatsoever. And so I brought this to the manufacturer's attention, and we were going to buy some new drives on another machine, and they said, well, don't worry, we have resolved the bearing fluting problem. You will not have bearing fluting on this machine. They'll be young and stupid, I believe it. Anyway, what I found out from the factory, this is what came out. This was mounted to there's a brush in here, you see it broken off, but it's a brush in there. And what happens is that brush rode directly on in the shaft and rode directly on the thing. We found out that this exactly worked exactly the same way this one did. So even just a year and a half ago, I saw a brand new motor come from the factory with this brush on it, with cosmoline on the shaft, and this brush riding on top of the cosmoline.
What is cosmoline?
Cosmoline is keep the shaft from rusting in transit. And this was their answer. The problem is it simply does not work consistently.